That's what I'm working on right now. So I was able to get this buddy right here, which is a 300 watt inverter. A couple of USB ports on it. Pretty simple unit. I paid maybe $12 or $8 or something like that out of it. And I just have these clamps on it right now. It also came with this, which I'm going to cut apart because I'll never use this piece on it. Also bought this. So this mess right here, it's hard to tell, but these are battery cells. There's 5 here, 5 here, and 5 down the middle. The butts that you see right here are negatives. The silvery entries here, those are positives, and those are negatives. So what this is all of these are in parallel. This string right here, 5 is in parallel. This string here in 5 is in parallel. So each one of these individual cells is 20 watts, or 19.3 or something in nominal voltage, but around 20. So you have 5 of them, 5 of them, 5 of them. Should be 300 watts in this little cell right here. And this buddy was salvaged out of a medical device. So it's not a pretty looking device, but works. Supposedly has 95% of the capacity. What you see on the left with the red wires, there's 2 big thicker red wires. Those are both pulling off of positives on the side here. And 2 thicker black wires, one at the top, one at the bottom. And those are all negatives. And these little red, green, and white cables off there. The red strand is hooked to this bottom row. The green one's the middle row, and the black one's the top. And the parallel cells, this entire line along here, the voltage across these is 3.93 is what I have to charge to now, but I'll go up a little bit higher when I'm actually using these. And the next row is 3.93 and the top one is 3.93. So you add those together because the string right here is in parallel, and then it series connects the 3. So if you were looking at notation, it'd be a 3S5P, something like that. So these sensors, each one of those represents a connection, and then that of course is a negative connection to each one of these rows, and then you balance them so that this row right here, even if you chart it up and it gets a different voltage than these other rows, it'll balance through these connectors here. And I have a board to do that. And that board's gonna sit up here. So the idea is I'm gonna mount this unit on top with this underneath. I'm gonna run a shorter cable down to the power here. And this buddy right here goes over to a, this is a 20 watt LED light, but 20 watts AC, which was the reason I had a problem with it. This is another one of the near free discounts I got. So when you connect it to here, and that's connected to the battery here, that'll run that. If you had to guess on amount of hours, it should be less than 15 hours of constant running. In theory, it's a motion light, so no telling how little it'll use. So when I said that there was 2 negatives coming in, I'm going to hook a balancing board into this middle here to these little sensor cables here. One of these will be hooked up to the inverter at the top, and then the other one coming off will be hooked to a charge controller, which I haven't got a charge controller yet. But I need to pick up a charge controller that'll handle the correct voltage for these buddies. So to get an idea of what the final product will look like, I'll have a charge controller either mounted on the top are out on this end. And that'll go out to a small solar panel. I'm guessing like a small 50 watt or maybe a 20 or 30 watt panel. And that'll go into the charge controller and charge the battery. And keep these topped up during the day. The inverter will stay on all the time, and at night it'll connect up and run the lights, and this will all sit outside.